Hello, everyone. I'm Weiyi, a PhD student from the Rhineland Study, German Center for Neurodegenerative Diseases. Today, I would like to share with you one of the latest studies from our group, automatically segmented olfactory bulb volume as a quantitative proxy of olfactory function. Some of you might not be familiar with the Rhineland Study. We are an ongoing community-based cohort study in Bonn, Germany from 2016. All inhabitants aged 30 years and above of two geographically defined areas are invited to participate. The study is scheduled to run for decades, and participants will be re-examined every 3 to 4 years. Our main aims are to investigate the modifiable and non-modifiable causes of neurodegenerative diseases and to find biomarkers identifying individuals at risk for neurodegenerative diseases. From this slide, it shows our imaging protocol. We acquire a 14-minute core protocol, including structure, diffusion, and resting state functional MRI, and a body fat image with our high-resolution 3 Tesla scanner. And we also have a free protocol for 10 minutes, which includes various novel sequences, can vary from different subsets. So back to our topic. Olfactory dysfunction is something you might hear about or even experience recently, characterized as a reduced ability of odor detection, identification, or recognition. Olfactory dysfunction is relatively common in adults, especially in the elderly, and it's of our interest as it's reported as an early symptoms of many neurodegenerative diseases, for example, Alzheimer's disease, Parkinson's disease, and multiple sclerosis. To study on the neural basis of olfaction, olfactory bulb is particularly interesting as the first relay between peripheral and central olfactory pathway. It could help integrate and process the odor information. And the recent studies proposed olfactory bulb as the entry site for prion-like propagation in neurodegenerative diseases, for example, the amyloid deposition in Alzheimer's disease. Some studies also reported that olfactory bulb volume is associated with olfactory function, and it decreased in odor dysfunction patients. Among these studies, previous work from our group examined the volumes in several regions of olfactory system, especially the volume of manually segmented olfactory bulb and central olfactory structures in 541 participants from the Rhineland study, and correlated this with odor identification function. The study showed that olfactory bulb volume was positively correlated with odor identification ability in all age groups and played as a mediator in the association between volume of the central olfactory structures and olfactory function. Our studies show that olfactory bulb holds promise for serving as a potential biomarker that could be added to clinical routine for assessing olfactory dysfunction or who at risk for neurodegenerative disease. But the problem is the lack of robust automatic segmentation tool, which allows us to measure olfactory bulb in vivo in larger sample. So how could we manage it in a larger population? Santiago from our group proposed an automated olfactory bulb segmentation pipeline last year, which can segment the olfactory bulbs with high accuracy and reliability. It shows good generalizability also in the human connectome project dataset. So with above pipeline, we would like to assess olfactory bulb volume as a quantitative proxy of olfactory function in the general population, by describing the variation of olfactory bulb volume and odor identification ability across the adult lifespan. And also, we would like to examine the association between olfactory bulb volume and odor identification ability. Last but not least, we would like to evaluate olfactory bulb volume as a predictor for olfactory dysfunction. The study is based on 3,347 participants in the Rhineland study. 58% are women, with mean age of 54.4 years old. The mean olfactory bulb volume in our population is 52.2 cubic millimeter, and all the automatic segmentation were visually inspected. To assess the odor identification, we used the 12-item sniffing stick test, and the mean score is 10 in our population. We also took the known risk factors for olfactory dysfunction into account, including smoking status, ApoE-LLL4 carriers, nasal congestion, cold, and heavy drinking. To better describe the olfactory bulb volume and olfactory function across the adult lifespan, we have these two plots. From the left plot, you could see that olfactory bulb volume slightly but steadily decreased with age, and so as the ability of odor identification, which measured using C12 score. We further investigate the currently known risk factors that possibly affect either olfactory function or olfactory bulb volume. Based on the model, we decided to include sex, age, and nasal patency as covariates for the following analysis. We use the linear model as above to evaluate the association between olfactory bulb volume and C12 score. After bootstrapping 5,000 resampling, olfactory bulb volume has an effect of approximately 0.011 on odor identification. Then we evaluate olfactory bulb volume as a single predictor for anosmia and hyposmia. To reduce confounding by age and sex, we use the residual olfactory bulb volume after adjusted for both factors in the prediction model. For predicting hyposmia, which is characterized by diminished odor identification, we found that adjusted olfactory bulb volume works poorly with area under the curve of 0.51, which might be caused by that C12 is not the most ideal test for identifying hyposmic individuals. To better address the topic in the general population, we stratified the sample into 3 age groups with equal number of participants. And we found that adjusted olfactory bulb volume performs similarly across the 3 age groups with area under the curve of 0.5 to 0.53. For predicting anosmia, which means loss of odor identification ability, we found that adjusted olfactory bulb volume works better with area under the curve of 0.63. And in the 3 age groups, it performs well, especially in young and middle age group, with area under the curve of 0.72 to 0.79. In conclusion, olfactory bulb volume and odor identification ability steadily decrease with age. From previous described risk factors, only age, sex, and nasal congestion were found to be significant correlates of C12 score. Olfactory bulb volume is associated with C12 score after controlling for covariates. Olfactory bulb volume shows promise in classifying anosmic but not hyposmic individuals, especially in younger age group. However, the prevalence of anosmia in our population is rather low, especially in young participants. Our findings still need to be validated in a cohort with higher anosmia prevalence. Thank you for listening. Our post number is MT949. Looking forward to chat with you in person.